Hello and welcome to another video. In this video we're going to be working on Task Scheduler, and in the problem you're given an array of tasks, each represented by A to Z and a cooling time. Each cycle or interval allows for the completion of one task. Tasks can be completed in any order, but there's a constraint. Identical tasks must be separated by at least n intervals due to cooling time. Return the minimum number of intervals required to complete all the tasks. So in this first example it's 2, because you basically, so let's say you do something like this. You want to separate out your A's. You need two things between every single A. So you can have like a B, and then here we'll call like I guess like a star is going to be the interval we have to wait, the idle interval. So we have to wait here because we can't do like A, B, B, and if we do B we can't do it either. So we have to put a star here, and then we put a B here. And then same thing, we have to put a star here, and then it would be like this. And so this is 8 total. And you can try it with B's, it would be kind of the same thing. This is like the only way you could do it. You have to have 2 idle cycles. In the second example, you have to have 6 total, because you are able to do this without any kind of like idle period. So for example, we can just take like A, and then we can take C, and then we can take B. Or actually, you only have to wait 1 between, so it's even easier than that. So you can do like A, B, C, D. There's a bunch of different ways you can do it, but this is one of them where you have no idle time at all. And in the last example, you have 3 A's, 3 B's, and you have to wait 10 cycles. So let's just say it doesn't matter which one you pick first because they're the same amount of time. So we could have like A, and then we can only pick a B after that. Then we have to have an idle cycle because we need 3 waiting times. And then we still need another idle cycle because we need 3 between every single one. So it would be like this. And then we could do it again. So A, B, star, star, then A, B. And so here we have 6 plus 4 idle cycles, so that's 10 total. So there's kind of 2 ways to do this problem. One's intuitive and one's not super intuitive, but once you see it, it makes a lot of sense. So obviously what you're going to want to do is you're going to want to count up like the number of times each letter appears. I think that part is pretty straightforward. You can just make a hash map, and this is very useful because there's only 26 letters. Making a dictionary of letter counts is basically free. It's a one space because there's only 26 letters, so this can be like a billion. It's still only 26 letters. So once you have our counts, let's say we have like A occurs, just give some sample example. A occurs 6 times, B occurs 4 times, C occurs 2 times, and then we have like D occurs 2 times, F occurs 2 times, let's say. Okay. So one way to do it is to just make a min heap, or a max heap, I guess. And it's kind of obvious that you want to use the letter that appears the most first, because we can have an example of where, like, let's say N is 2, and we have like something like A, B, C. So if we were to use an A first, then here we could do something like this. But if we use a letter that occurs less, and then we use an A afterwards, now we don't have like enough letters to fill between the 2 A's, right? So if we do like C, now we don't have another letter to fill here, so we need a star. So you basically use the letters that appear less for fillers for the letters that appear more. And if a letter occurs the same amount of time, you can do that. That's fine, because like let's say A's and B's occur the same amount of time, you just do like A, B, A, B, A, B, A, B, assuming you don't need any more fillers here. So once you intuitively figure out that you want to use the letter with the biggest count first, you can just do like pretty much just like a run of this. So essentially what you do, let's just kind of walk through this, is you make a max heap of all the letters, and then you basically just write down what time you're on. So for example, if you use the letter A at time 1, then if you need an interval of 2, it's going to be available again at time 4. And you just go like 1 second by 1 second by 1 second. And that basically works. So essentially you would put into your min heap, you would put in, or max heap, you put in like 6, and then A, and then, yeah, that's basically all you need. So your max heap will be like 6A, 4B, and then 2C. I don't even know if you need the letter, because like the letter you put doesn't really matter. You're just kind of figuring out like, do I have something I can put in? But regardless, 2D, 2F, and then you just say like, okay, at time equals 1, I will use. So basically what you do is you have a heap like this, and then you have probably another heap of the times your items are available. So let's say at time equals 1, I will use an A. So that means I have 5 A's left, and my A is available at time equals 4. So you put this A into another heap. So you'll just say like, okay, I put this A into another heap and it's available at time equals 4. And then for every single time, you just take your other heap with the items that you've used, and you make sure the stuff you've used is available now, and then you put that back into your other heap. And so that does work. And I'm not going to go too much further into this. This is basically just like you have available servers, and used servers are available things you can use, and then like things that you're using, and you can keep doing this, and this will basically work. And then essentially what will happen is, I will say one thing is, if you're at a time where you have nothing available, like if everything is used, then you would basically say like, okay, for that time I'd have to use a star or like an idle time, and then that's how you can figure out like how long it takes. So anytime you have nothing available, you just say like I use a star and keep going. And then whatever time you're done processing everything, like whenever everything goes to 0, that's when that's what you return. So let's go through the more optimal solution, because with 2 heaps, it's essentially going to be like n log n, and you also need the heaps. But the space for the heaps is still basically a 1 because you only keep track of the letters. But let's go through the optimal solution that's a little bit less intuitive. So let's go back to our example of the same letters that we have. So let's go back to this one. So basically, well, let's say n equals 3. Because you know that you're going to use the biggest letter first, you pretty much just want to use that as often as possible. So what you really want to do is you want to like use an A, and then you want to have, so if n equals 3, we need 3 filler letters. So it's going to be like filler, filler, filler. Then you want to use another A, filler, 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 another A, and so on, right? So until 6 times. So 5, 6. Oops. Okay. So we have 5 groups. And this is important, so we can write this down. So we have 5 groups, and we have 15 letters total that we need to fill. And then basically we need to figure out if from every other letter, like once you have your biggest letter, you basically need to figure out, okay, if I take every other letter, can I fill all of these? And if I can, then I don't need anything idle, like I don't need any idle time. And if I can't, for everything I can't fill, I will put in a star. So let's say let's say with these letters, you were able to fill in let's say you were able to fill in like whatever this is, 10, and we needed 5 times 3, so we needed 15. So that means we have to have 5 stars, like best case scenario. Like even if we're able to fill all this in, we need to have 5 stars. So let's actually change the numbers here a little bit, just so it'll be a little bit more interesting. So let's say B is like 6. And then, actually, I think this is fine. Let's just leave it like this. So that's kind of the idea, is you can easily figure out like how many of these groups you have, because if you have six A's, like whatever your biggest letter is, all you really need now is your values. So your values are going to be like 6, 6, 2, 2, 2. And you can actually, you don't even care about the letters, all you care about is the value. So we can just sort the values in decreasing order. We don't really need to sort, but it doesn't really matter because you only have 26 values. So we can just sort them not in decreasing order. So it'll be like 6, 6, 2, 2, 2. Then you take your biggest value, and this is like your A's. But like I said, you don't really care about what letter. You just care about that, like this letter is your biggest letter, and this is the one that's going to go like this, and then all these gaps are the rest. So you have 5 groups because your groups is biggest count minus 1, and then your items equals groups times n, right? Because this is how many like items you need between each consecutive letter. So this is going to be groups. Let's actually put it over here. So like this. So how do we do this efficiently, right? Like how do we figure out if we can just fill all these out? So we can actually go letter by letter. And it turns out that you can't put, because you need this gap of 3, you can't put the same letter twice in each group. Like the way we're going to have these groups, no matter what this n is, like if n was 5, we'd have a group of 5. We can't do something like B and then put another B here. So in order to put in letters, we have to put in letters in different groups. So like we can put in a B here and then like a B here, but we can't do it any other way. I guess it doesn't really matter. It doesn't really matter like which way you put it in, like this or like this or like this or like this. It doesn't really matter. But essentially, as long as you do have a space, you can put in the letters like that. So if you have 6 B's, because we need, like, each letter can only fill in 5 groups maximum. Because that's what we're concerned about. Like, or not 5 groups, but five of these items, 5 of these, like, underscores. So because we can put in a B here, let's say B here, B here, as long as we have enough of the letter, obviously. And we can't put it in any more than that. So each letter can fill in 5 at the most. And we're just gonna, we don't really need to care like how we put in the letters. It's always possible to put them in so that if there is space, it's always possible to put them in so that they go into different groups. So let's say like the B, let's just, for example, to show, we'll put in a B like this. So we had 15 items we needed to fill. So if we had 15 items we needed to fill, all we need to do is go through each of these letters and then figure out how many letters it can contribute to these underscores. So this letter that appears 6 times, which is our B, can contribute 5 letters because it can fill in all of these. Then this letter can contribute 2, right? Like we can, doesn't really matter how, we can do something like this. It's always possible. So we contribute 2. Then this D can contribute 2 as well. We can always just put it into the next group. And then this F can contribute 2 as well. So F, let's say. We just literally take like the next available letter in each slot. So now we have 1, 2, 3, 4 gaps. And because we have 4 gaps, that means we need to put in 4 of the idle times. So we basically just go through every letter, figure out how much it can contribute by the most it can contribute is the number of groups, right? So if you have 5 groups, the most the letter can contribute is 5. So if a letter has a count of greater than 5, it can only contribute 5. If it's less, it can contribute all of it. And then you basically just figure out, like, do I have enough letters to fill this out, or do I need more? So in this case, we needed more, right? We needed 1, 2, 3, 4 more, I believe. I think. Yeah, because it's 5, and then 6, so it's 11. So yeah, we need 1, 2, 3, 4 more. So we know we need 4 idle times. And then if we know we need 4 idle times, we still need to put in every other letter. So we just take the sum of the counts. So this will be like 6, 6, 6. So it would be 4 plus 18. And then we have 22. So this will take time 22 for this example. So let's walk through now our examples that we had originally with this kind of thing to hopefully understand it a little bit better. So let's delete all of this, and just, this one was a little bit complicated. And this is a pretty complicated solution, so if you do have any questions, feel free to ask. Okay, so let's just walk through this example. So here we have 3 A's. So remember, we don't really care about the letter, so we just have 3 A's and 3 B's. So we can just sort it in descending order. So we know we have 3 A's, so our groups is going to look like, obviously, like A, and N is 2. That means we have, so we have 2 groups, right? The groups are going to be between the letter. So if the biggest letter occurs 3 times, the number of groups is the count minus 1, and then each group has 2 items because N equals 2. So it's going to look like this. This is the structure we want. Okay. And now we see how many letters the B can contribute. So the B can only contribute, remember, you can only contribute the number of groups letters, so there's only 2 groups. So the B can only contribute 2 letters here. So we needed 4, we contributed 2, so that means we have, no matter how we put it, we have 2 idle times. So let's say we put it in like this. We have 2 idle times. So then if we have 2 idle times, it's going to be whatever the idle times is plus the length of the initial sequence. So 2 plus 6, which is 8. Okay, so let's do the same thing for example 2. So here we have A with a count, or like I said, we don't care about our letter. So A has a count of 2, B has a count of 2, C has a count of 1, D has a count of 1. So our biggest letter has a count of 2, which means it's going to look like, let's call this L for letter. It'll appear like this. N is 1. So we only need 1 group of 1 letter. So can we fill in 1 letter? Obviously we can. So like this can easily contribute 1 letter. So because we don't need any idle time at all, that means we'll just have 6 letters total. So that's just fine. And then finally for the last one, so A has a count of 3. Or like I said, we don't need the letter. B has a count of 3. So our biggest letter has a count of 3. So letter, letter, letter. Our number of groups is 2, the count of the letter minus 1. And our number of items in each group is N. So it looks like this. Then we figure out how many letters each letter after that can contribute. So this, we have 2 groups, so this can only contribute 2 at the most. So we only have 1 other letter, so this can contribute 2. We needed 6, so we're going to have 4 idle. So 4 idle plus our 6 original letters is 10 total. And so that's kind of the idea. Definitely hard to come up with, but once you realize, like, okay, ideally, the most I can ever use is the biggest count followed by, like, the gaps I need, then you can figure out, like, how much of the rest you can fill in, and then you figure out how much idle time you need, and then the answer is just your idle time plus your original thing. So we can code that. So we can say counts equals counter of tasks. So this will just give us a letter and a count. We can take the values and we can sort it in decreasing order. So I believe we should just be able to do this. And we can, like I said, you don't really need to sort. You can just like take the biggest value. It's fine too, but we can sort because this costs us nothing. So I believe we should just be able to do this. Now we are going to take our biggest item. So we'll say like our max val equals count 0, and then we go through the rest. So our groups equals max val minus 1, and our total items that we need is our groups times n. Then for count in counts, or we want everything after the first one, so we could do a couple things. We could do like this in counts. We could do a slice, which is fine. So essentially, like, we have our counts, and then we just say, okay, let's just look through everything other than the first one, because the first one is the letter we spread out. So for this, items minus equals, and remember, the most you can ever contribute is, the most the letter can contribute is the number of groups, so we can just say, like, minimum, I think, here, of groups, and count. So we'll subtract, so like if groups is 6 and this letter has a count of 2, we'll subtract 2. If groups is 2 and the letter has a count of 6, we'll subtract 2, so it works out. Yeah, so we do that, and I think that's all we need here, I believe. Now we check, so items can be negative now. Like, obviously, we could have stopped it earlier, but it doesn't really matter. Like let's say our thing is like this, and we have a bunch of letters, right? Like, let's say every letter, like this occurs 3 times, and then we have like 25 other letters that occurs once. Items will be negative, but we don't really care if it's negative. We just need to care that it's, if it's negative, then we don't need any idle time, but if it's positive, we do need idle time. So we can say like idle time equals the maximum of items and 0. So if items is negative, we'll need 0 idle time, and if items is positive, then we need whatever the items is. Then we just return the length of tasks. So we obviously need to use all the tasks plus the idle time. And let's see. For count and counts, oh, it's because I think I need like this. I almost never use slicing, to be honest, because it's like less performant than like other stuff. So, okay, so there we go. Yeah, so this works. And like I said, you can do the heap. This is just going to be more efficient. So hopefully that makes sense, how you just figure out, okay, the least, the most I need to use is the biggest count spread out by these groups, and then I can figure out how much each letter can contribute and get the idle time from there. So this is going to be, let's see here. So it's basically O of n, because this counts, like to get the letter count itself is O of n. To sort 26 letters when your array is like 4,000 is O of 1. Because it's only 26 letters. You can say like O of 26, log 26, or whatever you want to. And then the rest of it, yeah, like this whole, all this other stuff is super fast because your dictionary is only 26 letters. So everything, all this other stuff is basically O of 1. This is the only stuff that's O of n. And like I said, it's base O of 1 because we're only storing a dictionary of letters, which is only 26 letters. So yeah, this is definitely kind of a tricky one. I think the heap solution you should be able to come up with, like in an interview. That one's a little bit more intuitive. Just like use whatever's available. And this is I don't want to say it's like super common, but it's reasonably common, where you have some thing that you can use, and then whenever you use it, you put it into used, and then you reallocate the time for it later on. Like this is like I said, there's like a process tasks using server. There's probably like 5 problems of this kind of format. The greedy solution, however, is definitely hard to come up with. I wouldn't expect people to come up with it if they haven't seen it before. But it is good to see it and then like redo this problem like a month later and be like, oh, I remember there's some kind of greedy thing what like, now that I know that there is something, let me try to think of it. And like I haven't done this one in a while, so I was able to think of it, yeah, because I knew there was something like this that existed. But yeah, in any case, that's going to be all for this one. If you did like this one, please like the video and please subscribe to your channel, and I'll see you in the next one. Thanks for watching.